Okay, in solving force systems problems, there are various approaches that we can use. Of course, we can use a trig-based approach where we use, say, law of sines, law of cosines. A real popular approach, this is one I use most of the time, is the use of rectangular components. Basically, the idea is that you take these forces and you break them down into their x and y components. So the example that we have here, we have this I-beam in which there's 3 cables that are attached to this I-beam. There's a force 1 of 600 newtons at 45 degrees from horizontal. You have a force 2 of 800 newtons at 60 degrees from the vertical. And you have this third force of 450 newtons at 75 degrees from the vertical. And what we're after is we like to know what the net or the resultant force is with these 3 forces acting on it. Okay. So the approach that we're going to take is we're literally just going to go force by force, and we're going to write down the x and y components of this, and then just sum up all the forces in the x, sum up all the forces in the y, and see what we have for our resultant. So I'll go ahead and start over here with the F1 force. Okay, so F1 is 600 newtons, and it's going off on the right. Now I should mention that I have my reference axes drawn here, where x going to the right, y going upward is positive. So the 600 Newton force going off to the right, going up and off to the right, is going to have an x component of 600, and the x piece of this would be cosine 45. Okay, and that's positive because it's going to the right. It has a y component of 600 times the sine of 45. Now let's do the same thing for the other forces. So for F2, okay, in this case it's a little different because the angle's based off of the vertical. If we want, we can, either way, we can envision it also as having an angle right here of 30. So I'm just going to use the angle that was provided with 60, okay? But again, you could also do things in terms of 30. So the F2 in the x direction, okay, we know it's negative because it's going to the left, okay? If I use the 60-degree angle here, I'm going to look at this piece here, which would be sine of 60. So I would have 800 times the sine of 60. And again, if I thought about that from the 30-degree angle perspective, I could also have minus 800 cosine of 30. So however you want to. I usually just use the angle that's provided so I don't get things confused. Okay. F2 is going up, so it's going to be positive in the y direction. And then this angle, this side here, would be the cosine of 60. Okay. And we'll do the last force, F3. Okay. F3 has a magnitude, let's see, so F3 in the x direction. Okay, so in the x direction, it's also going negative. It's got 450, and it has an x component. And again, I'm just going to use the angle that's given here. So for this angle here of sine of 75, the horizontal component would be opposite that angle, or sine. So I have minus 450 times the sine of 75 degrees. Okay. The y direction in this case of that force is also negative. It's 450, and this would be the cosine of 75 degrees. And again, if you rather, you could write down what this angle here is 15, right? It'd be 90 minus 75, and you could write everything in terms of 15. Okay, so now that I've broken down the 3 forces, what I'm going to do now is I'm going to find, let's just call it the net, oops, if I could write, net x direction force, okay? So the total force in the x direction, all right, is going to be the sum of these 3. So I've got 600 cosine 45, from there, minus 800 sine of 60, okay, from here, and then minus 450, was it right? That's right, sine of 75. Okay, that gives me a net force in the x direction of minus 703.2 newtons. I'm just going to underline that for now. Okay, and then let's do the net force in, let's see, well, I guess I should be consistent. Let me go ahead and just fix that real quickly. So I'm going to call this just the net y direction force. Okay, so I'm going to sum those up. I've got, this is positive, sine of 45 degrees. I've got this piece here also is positive. Okay. And then I have this last piece here, which is negative, and that would be cosine of 75 degrees. Okay, so Fy comes out to be 707.8 newtons. Okay. So our net force has a negative component in the x direction and a positive component in the y direction, right? So if we drew this out, okay, what we would have is we would have a force in the x direction of 703.2 newtons. Right. Okay. In the y direction, it has a magnitude of 707.8 newtons. Right. So our resultant force is kind of like this. It's going off. Okay. And the magnitude of that, we could just use Pythagoras theorem and just say minus 703.2 squared plus 707.8 squared. Okay, that gives you a magnitude of, let me take a look at my cheat sheet there. I got 997.7 newtons. Okay. I'm running out of space here, but if I want to do the angle, all I'm just going to do is a tangent of theta is 70, that would be just the 703.2 divided by 707.2. Theta comes out to be minus 44. Oops, let me fix it. A little sloppy there. You guys won't be able to read that out afterwards. There we go. Okay, let's try that. Minus 44.8 degrees. Okay. So the net force, when we take all this together, the net force is just some force of 997.7 going off at an angle theta, right, which obviously is this direction here, from the y-axis of 44.8 degrees. And that concludes this example of solving a force system problem using the rectangular component approach.